Okay, next set of reactions. We're still with aromatic aldehydes only. So this is by side chain chlorination. Okay, so again, based on the name, yeah. So you start off with benzene. You start off with toluene, sorry, and the side chain, the CH3 part, उसका chlorination कर लो पहले. So expose it to CH2 in sunlight. Sorry, Cl2 chlorine in sunlight. The side chain gets chlorinated. So you control the chlorination by controlling how much light it is exposed to. You also control it based on the Cl2 so that you get CHCl2. So this is called benzyl chloride. And this on hydrolysis, treated with water, like treated with steam, basically 100 degrees Celsius pe, gets oxidized to benzaldehyde. Again, there's no detailed mechanisms for all these reactions. You just have to look at them, know them. So this is free radical chlorination directly. Expose it to chlorine presence of light. The side chain only gets chlorinated because that's the only sp3 carbon hydrocarbon that you have. Now, when you like this on hydrolysis, it's oxidized to benzaldehyde. Okay. Then the last one in aldehydes, this is a named reaction. So this is called Gattermann-Koch reaction.
You gave this reaction in haloalkanes or something.
We had come across Gattermann-Koch, right? No, I think you had Gattermann reaction there. This is Gattermann-Koch reaction.
Yeah, that was only Gattermann.
Reactions, no, it's not multiple, just one single reaction. Okay, so in this, you start off with benzene. This, you just need to remember the reagent. So in the presence of CO and HCl, use anhydrous AlCl3 as a acts as a Lewis acid, or CuCl. So the CO and H, like hydrogen part, get added to the benzene ring, and this gives you CHO. So I'll do one thing. Preparation of ketones has 3 more reactions. Once we finish all the preparation methods, we'll go over the named reactions once again. Okay, just like summarize it. And then after that, we can move on to the properties.
What was the reaction after Stephen reaction? Can you 1 second show that? Just 1 second.
Huh. So preparation may, we have a total of 4 named reactions. We have Stephen-Rosenmund reduction, Etard reaction, and Gattermann-Koch reaction.
Etard, yeah.
All of them are for aldehydes only. Like ketones, we don't have anything linked. Yeah. Yes. Okay. Arya, Kaveri, yes, Rish. Okay. Now, last section in preparation, we're looking at preparation of ketones. So there's 3 reactions in preparation of ketones. The first one, again, we have acyl chloride. But acyl chloride plus we're using dialkyl cadmiums. Dialkyl cadmium. So it's a set of 2 reactions. Again, organometallic compounds are usually unstable. So first step, you need to prepare Grignard reagent. From Grignard reagent, using Grignard reagent, you prepare this particular reagent first. So Grignard reagent, you use dialkyl chain. You use 2 moles of Grignard reagent. You have 2 RMGX. Treat it with cadmium chloride, CdCl2. You get dialkyl cadmium, pretty straightforward. So this will be R2CD, so cadmium and 2 alkyl groups, plus 2MgXCl. Now take this dialkyl cadmium, treat it with acyl chloride. So again, so you have 2R dash C double bond OCl, 2 alkyl halide plus R2CD. This will give 2R dash C double bond O R and cadmium chloride, CdCl2, regenerated back. Okay, so first step, in this reaction, we're preparing dialkyl cadmium using Grignard reagent. So why do we use Grignard reagent? So you first prepare Grignard reagent so that you get the Carbanian alkyl chains, R minus. Treated with cadmium chloride, it's pretty simple, like it's a straightforward double displacement sort of reaction. So in place of halogens, you have the R minus getting bonded to cadmium. Then you take the dialkyl cadmium that is formed, treat it with acyl chloride, and R dash will remain as it is, bonded to C double bond O. So just in place of chlorine, you end up getting the hydrocarbon chain attached, alkyl part attached. So this is a very good method because you can customize it. So everything is in your hands. You choose the right Grignard reagent and choose the right acyl chloride to get the ketone that you want. Okay, next, from nitriles. Okay, I'll just pause here. Let me know when you guys finish writing. We'll discuss nitrites. Okay, so in this case, okay, Arias don't spell as okay. So nitriles are CN. Okay, if you remember, if you were preparing aldehydes from nitriles, you started off with sources of hydrogen and then you hydrolyzed it to get oxygen. In this case, you want more alkyl groups to be attached on the other side of the carbon. So here you treat nitriles again, source of alkyl group, again Grignard reagent. So treat this with Grignard reagent. Let me write it as R dash MgX. In the, like, do this reaction in ether. Okay, so triple bond may, one bond breaks, then you have R minus and Mg is always electropositive. This will have a positive charge, this will have a negative charge. Now, what will get attached to what? So you have R, C, the triple bond breaks into a double bond, and the Grignard reagent is added to carbon and nitrogen. So which part is added to carbon? Which part is added to nitrogen? You figure it out.
R will be added to carbon and MgX will be added to nitrogen.
That's it. So nitrogen more electronegative. So the positive part added to nitrogen. So this becomes NMgX. And you want to get rid of this on hydrolysis, acidic hydrolysis. This is substituted with oxygen. Again, similar to what you saw in preparation of aldehydes. So the difference between both the methods is, in the case of aldehydes, because you wanted to add an extra hydrogen here, you use sources of hydrogen. You had H2 in the presence of palladium or barium sulfate, or you use the mixture of stannous chloride with HCl. All of these are sources of hydrogen, or you use dival H. In the case of ketones, because you want alkyl groups on both sides, you used Grignard reagent. So Grignard reagent, always source for alkyl groups. You want to increase the number of carbons in the chain, or you want to introduce alkyl group in like another compound, like in these cases, you always go with Grignard reagent. So the difference is, in the case of acyl chloride, you converted Grignard reagent into like dialkyl cadmium, and then you added the alkyl groups from cadmium onto acyl chloride. In this case, you could directly react Grignard reagent with the nitrile. Okay. Then final reaction. Okay, let me know once you guys have finished noting till here, and we'll do the next one. Next is going to be slightly different from this pattern. So Kaveri, Sia, and Spira, I guess, finished noting. Ariel's finished. Okay. Last reaction. So this is again directly from benzene. So we're looking at aromatic ketones or any substituted benzene. So either way, start off with a benzene ring, or if you have substitutions, also the same thing. You want to introduce a C double bond O with alkyl group. So the source for that would be an acyl chloride. So take a Ryl or an R group attached to C double bond OCl in the presence of anhydrous AlCl3. You get C. Let's put it this way. C double bond O. This is attached to either R or AR, depending on what you started off with. Do you guys remember what is the name of this reaction? Does it look like anything you've studied before?
Friedel-Crafts.
Yeah, this is Friedel-Crafts. Friedel-Crafts acylation. So if you, in case you use a substituted benzene, then you're going to get that respective product, either ortho para position or the meta position. So finish writing, and then we'll go over like the named reactions again.
This is like the third point under preparation of ketones only, na?
Yeah, it's preparation of ketones. Again, why can't we use Friedel-Crafts acylation to prepare aldehydes? Why not with benzaldehyde?
Could you repeat?
Like, why can't we use this reaction to prepare benzaldehyde?
There's no H to be substituted.
It's CO. No.
I mean, that's in your hands, no, Sia. You choose this particular reagent based on what you want to be substituted here. C double bond OCl is the main part. So why can't we, like benzaldehyde ke liye you want CHO, right? So why can't you use that particular reagent for Friedel-Crafts reaction? Why can't we prepare benzaldehyde that way?
Is it because we can't, I don't know, something with AlCl3 being more electronegative or something as compared
But
to
it's the opposite of electronegative. It acts as a Lewis acid. It's an electron acceptor.
Oh wait, it forms a salt or something like that with aldehyde, or is that something else?
No, it's something else. Tell me, if you want to prepare benzaldehyde, along with like, okay, benzene is one thing. What is the reagent you're going to take in order to prepare benzaldehyde? So benzaldehyde, you like write the product here. You want C double bond OH. So benzene pe hi substitute ho raha hai, so that is one of our reactant. So what should you take along with benzene?
HCOCl.
HCOCl, that is correct. And what do you know about HCOCl?
Nothing.
We know something.
Nothing.
We just discussed it in a previous.
Unstable
Acyl chloride.
Yeah, this is unstable at room temperature, formal chloride. So this is not stable. So we can't use this particular reagent. So this reaction is not going to happen. That's
I
why.
don't understand anything.
Why? This is way before your usual time, Kaveri.
I didn't get it. Why? How do we have to use this thing? COCl.
See, observe this reaction. Like you've studied Friedel-Crafts reaction pehle, na? So if you take RCOCl, AlCl3 takes away the Cl and whatever remaining part is there gets substituted onto benzene. It's an electrophilic substitution. Remember? We've been studying this from grade 11. Like every single chapter, there's a Friedel-Crafts reaction that comes up. Or electrophilic substitution at least. So yeah, like if you apply the same thing in order to get benzaldehyde. Benzene pe what did we substitute?
Oh yeah, we need.
Third part, right?
But we need benzene COCl, na? Like we need aryl chloride, no?
नहीं, benzene पे substitute कर रहे हैं ना? We already have benzene. So we are substituting only this part. So if I take CH3COCl, then I end up substituting, like, take away chlorine and the rest of the part gets onto the benzene ring. So I get benzene and then C double bond O, CH3.
Okay. So then how is this related to what you asked about
So
benzene?
what I asked is, can we prepare benzaldehyde by this method, or why can't we prepare this benzaldehyde by this method? So if I want to substitute C double bond
because this is unstable at room temperature.
this is the
Then
reagent we need to take, HCOCl. But
then
this
we
is
just don't use it at room temperature, right? No, like why can't we make benzaldehyde? It's unstable at room temperature, so we just change the temperature.
then the reaction will not happen. We did chemical kinetics, remember? Like you need that energy for a reaction to happen. So so yeah, just pay attention to these things. That's why we have those little notes like exceptions and things like that. So just remember, make note of these things. It can be asked in any other way, like other ways possible also.
What is R/AR?
Either RCOCl or AR means if I put a benzene ring over here, I get acetophenol.
So this benzene on substituted benzene is Friedel-Crafts only, no?
Yeah. So
So this is
R,
also a chain
R-
reaction.
this is, yeah, it would come under a name reaction. It's not a new name reaction, but yeah, it is Friedel-Crafts reaction. So if I use the AR part is this one, R part is this one. If I use this. If I use AR, I get acetophenol. And if I use RCOCl, that whole chain will get attached here. Just put a bracket. quickly guys, we have a whole bunch of properties left.
Sorry, today we'll do till where?
I was hoping to finish a couple of properties. So properties may we have nucleophilic addition, reduction, oxidation. Like there's 5 different reactions we're going to study, and within those also you have like multiple sets of reactions. I was hoping to do like get done with the simpler reactions, nucleophilic addition ones, so that tomorrow we'll deal with the more intense, like more complicated ones. Okay. Summarize the named ones. So first, we'd come across Rosenmund reduction. Do you know what this is?
From acyl chloride.
Acyl chloride plus
PDBS.
H2. Yeah, PDBaSO4.
Poisoned, that is poisoned by acid.
Yeah. Okay, so this is preparation of aldehyde. Next, Stephen reaction.
Nitrile plus SnCl2 vinyl chloride plus HCl.
Yes.
Give
Yeah. So first you get imines, and imines on hydrolysis, you get aldehydes. Next we have ETARD reaction. ETARD में क्या हो रहा है? This is an oxidation wala reaction. Toluene plus which one? Is it chromyl chloride or chromic acid?
Chromyl chloride.
Chromyl chloride. CrO2Cl2. And then you have in carbon disulfide. Then again on acidic hydrolysis gives benzaldehyde. And Gattermann-Koch reaction. So this benzene or
Benzene.
benzene, and the reagent
CO.
CO and
HCl.
L.
There was ClCl3 also.
You have
Oh,
anhydrous AlCl3. Yes.
so that is like or COs HCl or anhydrous
No. In the
ClCl3
presence of anhydrous AlCl3, like
or
COHC
CuCl.
acid, all of them. Or yeah, AlCl3 or CuCl. Any one Lewis acid required. Take the Cl away. This gives aldehyde. And Friedel graphs I'm not including because that you've been like studying since forever. These are the new ones, so I'll just summarize this. So these are named reactions with respect to preparation method, and all of them happen to be aldehydes. Yeah. So group all of them together. Okay, preparation of aldehydes may you have like these 4 reactions, and then oxidation may you have like 2 more reactions, and reduction may you have 2 more reactions. So if you just classify them, categorize them, it'll be much easier to remember. So break them down and classify them. Okay, Acha, before we get to chemical properties, we'll quickly go over some physical properties. Pretty simple. It's the same 3-4 points that we will always discuss, physical properties. The first one being the physical state of aldehydes and ketones. So methanol is pretty volatile. So methanol is a gas, formaldehyde is a gas, ethanol is a volatile liquid. And as the number of carbon atoms increases, the boiling point, melting point also increases. So the first few of them will be liquids, and then the higher aldehydes are all solids. When it comes to ketones, acetone is a very volatile liquid. Do you guys use nail polish? So you have the remover, right? Nail polish remover. So that is what acetone is. It's made up of acetone. So yeah, be careful. It's a very volatile liquid. You must have felt it. Like if you just dropped a couple of drops of like the remover on your hand, it dries up very quickly. It evaporates and you have that cooling sensation also. So that's because it's very volatile, very low boiling point. So it evaporates pretty quickly. So as the number of carbon atoms increases, the boiling point of ketones also increases. So that will be our next point when it comes to boiling point. Point 1 increases as the molecular mass increases. So basically as the number of chains increases, the boiling point also increases. The next point when it comes to boiling point is how does it compare with alcohols and ethers, because those are the other functional groups that also contain oxygen. So that's why we end up comparing with those. So if I have alcohols, ethers, and aldehydes or ketones, what would be the order? This I will highlight. It's important. Yeah, what would be the order? Maximum boiling point, which one will have?
Alcohols.
Correct. And the reason being?
Edge bonding.
H bond.
There you go. Yes. Then,
An aldehyde.
yes. Then you get aldehyde. Yeah. Then you have aldehydes and ketones. Because they are weak dipoles, followed by ethers. So even though ethers have oxygen, because you have like oxygen ka lone pair se and you have like carbon atoms on both sides, they end up being weaker dipoles compared to aldehydes and ketones. Okay. Next comes solubility. Do you think aldehydes and let's take like one thing, or yeah, let's take both of them. Do you think aldehydes and ketones are soluble in water or insoluble?
Lower ones will be soluble.
Yeah, just like with alcohols and mostly with alcohols, the lower ones will be soluble. I think even in ethers, the smaller ones are soluble. And as the hydrocarbon part increases, the solubility decreases. So
Because that's the hydrophobic part.
yeah. So methanol ethanol, and acetone are soluble in water. So these three are miscible, or like using the technical terms, you call them miscible in water. And the solubility decreases as the, guys, are you able to see, or should I write it in the next page?
I'm able to see.
Visible, right? Okay. So solubility decreases as the number of carbon atoms increases. And the reason why these three are soluble in water, like why are the smaller ones miscible in water? Because of
H bond.
H bonding, yes. So there is no hydrogen bonding within these atoms, but water has hydrogen which is electropositive. So with water, they form hydrogen bonding. That's why they're able to mix easily. But if you have pure methanol or pure ethanol, you just have the dipole interactions. You don't have hydrogen bonding inside them. So because of H bonding, you can be more specific. Because of H bonding with the water, not with their own selves. Okay. And final point, this is something that if you've been in a bio lab, you would have observed. What do you think they would smell like? Will they have any smell?
Sorry, we don't have those in our
Yeah, we can't relate
bio
to it.
lab.
What do you mean? Like bio is
We had a
subject, right?
beautiful bio lab, and they turned it into some other isolation room. And now we have some DIY bio lab next to the chemistry lab with like 4 organisms
We
there.
put a pillar in between the chemistry lab and then just wrote bio over there, and then all the bio people go there.
I am not a bio student, so
You're not. That's why I said those who have been to the bio lab. But Smera, even you should know. 9th May you had gone to school, no?
yeah, and they rarely took us to the labs.
We don't have we were
Ask that.
we were
Like,
out of thrown
not
out
what
of school.
Okay.
We
But
didn't touch any test tubes also in 9th.